Hello and welcome to another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 8cc, Lesson 5 on compound events. Unit 8 is all about probability and finding the probability that a particular event, that's just something that happens, okay? Finding the probability that an event occurs. Now in the last lesson we introduced some new terminology, things like sample space, right? Equally likely outcomes. This terminology is very, very important as we start to look at what are called compound events. Everything you looked at so far are what are called simple events, and let's discuss the difference between them right away. All right, so all probability problems you've seen so far, and I don't care how far back you go in probability, have been simple events because only one thing is happening. We spun a spunner, right? We flipped a single coin, we threw a single die, right? We opened up a single door, that's it. It's a simple event, and it's easy enough to say, here are my equally likely outcomes, here are how many fall into an event, so here's my probability. Let's take a look at that in exercise 1. Consider flipping a single coin. This is an example of a simple event. Letter A, list all equally likely outcomes in the sample space. All right, well look, I flip a coin, right? All the outcomes that can possibly happen, and we oftentimes use sets to do this, is I can get a head or I can get a tail. There are literally two outcomes. That's it, right? And they're equally likely unless you have what's known as a weighted coin, all right, which are hard to come by. Letter B, what is the probability the coin lands on heads? Express as a fraction, decimal, and percentage. Well, this is a piece of cake, right? So let's just kind of do it together. You know, we have two outcomes. The event that we're looking at is the probability it lands on a head, or a heads, or whatever, right? So there's one of the two that fall into it. So the probability that we're going to get a head is 1/2, which I hope you're all comfortable with is the same as the decimal 0.5. which is of course the same as the percent 50%. All right, and this is simple. And it wouldn't matter whether we were looking at flipping a coin or rolling a die once or, spinning a pointer, right? If there's only one thing that happens, it's pretty easy to say, well, here's all the equally likely outcomes, all right? Here's how many of them fall into the event that I'm trying to find the probability of. So I do that ratio of the number that fall into my event divided by the total number, and then I have my probability. Simple enough. But now let's talk about compound events. All right, compound events occur when more than one thing is happening. A good example would be flipping two coins at the same time. Two coins at the same time. So for the next exercise, you're going to need to have two coins. Whether you're doing this lesson from home, because maybe you're doing remote learning, or whether you're doing it in a classroom, you need to have two coins, okay? So let's take a look at exercise number 2 and see what it asks you to do. Working alone or in a team, flip two coins 30 times and note how many of each of the following occurs. All right, so in other words, I want you in a moment to pause the video and take two coins and flip them. And if they land on two tails, then I want you to put a tally mark here. Then I want you to do it again, and if it landed on a head and a tail, I want you to put a tally mark here. Flip it again, it lands on a tail and a head, I want you to put a tally mark here. Flip it again, it lands on two heads, put one here. I want you to do that again and again and again so that you've done it 30 times. You don't want to do it 10 times, right? You want to do it enough times that you start to see if these three things, and keep in mind, these are the only three things that could happen, right? If you flip two coins, you're either going to have two heads, two tails, or a head and a tail, right? That's it, all right? Doesn't mean that they're equally likely outcomes, but those are the only outcomes that could happen in our experiment. Okay, so pause the video now. This is going to take you a little while. This could take you 5-10 minutes, and that's okay, okay? Pause the video, flip those two coins 30 times, and then figure out how many total times of the 30 you got two heads, two tails, one head, and one tail. Pause the video now. Take as much time as you need to do this. And we're back. Now, there's nothing I can do to know what results you got. There's just no way to know, Okay, but I actually ran this experiment myself. I had fun with it. I didn't put the tally marks down, I just put my totals down. And what I found when I flipped 30 times is I found 7 of the times it came up as 2 heads, 9 times it came up as 2 tails, and 14 times it came up as 1 head and 1 tail. So we're gonna work with my numbers. I'm hoping that you got results that are relatively the same, but we'll kind of talk about that as we go. So, exercise number 3. Consider the results you found in the table. Answer the following. Letter A. Do the 3 events shown in the table above seem equally likely? All right. Well, maybe I need to, let me just put here 2 heads, 2 tails, 1 head, and 1 tail. Okay, just to make sure we know what each category. Well, looking at my results, looking at your results, right, hopefully the answer is no, right? No, right? If they were equally likely, then what we would expect to see is we'd expect to see roughly, 10 for each one of them, right? But what we're definitely seeing, right, and this gets to letter B, is that one of the events seems more likely than the other. So letter B. Which of the 3 events seems the most likely? All right. Now again, based entirely on my own numbers, the event that seems most likely is that we get 1 head and 1 tail. Now don't get me wrong, you could have gone through this experiment and actually gotten 10, 10, and 10. You could have conceivably gotten that. But you probably should have gotten results where you had more of these than these 2. All right. Now for letter C. Can you think of a reason why your choice in B would be more likely than the other 2? Why would it be more likely given that when I flip 2 coins, the only 3 things that can happen is getting 2 heads, 2 tails, or a head and a tail? Why is it that this one should still be the more likely of the 3? Pause the video now and see if you can think about that. Well, it's pretty basic, but still can be confusing. If I'm going to get 2 heads, there's only one way that I can have that happen. I get a head on the first coin, and I get a head on the second coin, right? So 2 heads can only happen in one way. You get on coin 1 a head, and on coin 2 you get a head. That's the only way it can possibly happen. That's it, right? And likewise for 2 tails, right? For 2 tails, the only way that's going to happen is that on coin 1 you get a tail, and on coin 2 you get a tail. That's it. But, right, for a head and a tail, there's actually 2 different ways that can happen, right? 1 head and 1 tail, well, that could happen in one of 2 ways. It could be that coin 1 you get a head and coin 2 you get a tail, or it could be that on coin, whoops, let me try that again. On coin 1 you got a tail, and on coin 2 you got a head. Now, if you don't like the idea of me saying things like coin 1 and coin 2, then maybe do a mental experiment. Maybe you color 1 coin blue and 1 coin green. Or maybe 1 coin is a quarter and 1 coin is a nickel. Do you know what I mean? Somehow you can distinguish between the 2. The plain fact is, if we had a nickel and a quarter and we got 2 heads, it's because we got a head on the nickel and a head on a quarter. If we got 2 tails, it was because we got a tail on the nickel and a tail on a quarter. But if we got a head and a tail, it could have been that we got the head on the nickel and the tail on the quarter, or the tail on the nickel and the head on the quarter, right? There are more possibilities over here than there are for these 2. And that's harder to think about because we have 2 things going on. We flip 1 coin, and then we flip the second coin. So let's see how we can be a little more organized about thinking about compound events, because they're really where the power of probability lies. listing equally likely outcomes for simple events tends to be really easy, right? It's just like, oh, I spin a pointer and it could land on 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or, I roll a 6-sided die just once and it can land on 1, 2, 3, 4, 5, 6. That's it. But for compound events, it's much more difficult. Often the key will be to break the compound event into simple events and then use some way to keep track of the equally likely outcomes. So in the next few lessons, we're going to be looking at ways that you can keep track of equally likely outcomes when 2 or more things are happening. All right? So let's take a look at exercise number 4. We're going to examine the 2 types of ways to keep track of equally likely outcomes from our 2-coin experiment. Letter A. Fill in the sample space table below and then use it to create an organized list of the equally likely outcomes. So, these are 2 different ways we can keep track of them, and they kind of work well together. Now, a sample space table. This is fantastic when you have just 2 things going on. Coin 1, coin 2, or maybe you roll a die and flip a coin, or maybe you spin one spinner and then you spin another spinner. And it's really nice because you list out all the ways one thing could happen, and then all the ways the other thing can happen, right? And then you can kind of say, oh, okay, so one way it could happen is if I got a head and a head, right? And we oftentimes list these in what are called ordered pairs, right? So literally the first thing is coin 1 and the second one is coin 2. It's like an XY pair, except literally the first number or thing in the pair is what happened to coin 1 and the second one is what happened to coin 2. So then I could also get a tail on coin 1 and a head on coin 2, right? Tail and head. But I could then get a head on coin 1 and a tail on coin 2, right? And finally, I could get a tail on coin 1 and a tail on coin 2. And what we see now is that there are 4 equally likely events in this sample space. All 4 of these, right? Now an organized list, right? An organized list would then be maybe taking something like this and saying, well, I could get a head and a head. Or I could get a head and a tail. Or I could get a tail and a head. Or I could get a tail and a tail, right? Those are the things that can happen. And what I'm really doing is I'm saying, well, if I got a head on the first coin, then what could I get on the second coin? Well, I could get a head. If I get a head on the first coin, what could I get on the second coin? Could get a tail. If I got a tail on the first coin, I could get a head on the second. And if I got a tail on the first, I could get a tail on the second. Either way, right, we have 4 total outcomes. Now, one of the cool things, all right, and we're going to see this theme again and again and again, so I'm going to keep harping on this. You can always figure out the total number of outcomes, equally likely outcomes, by taking how many outcomes there are from one part of the event, how many outcomes there are from the other, and multiplying. Not adding, multiplying them. So literally I have 2 outcomes from this coin that are equally likely, 2 outcomes from this coin that are equally likely, and because of that, I get 4 equally likely outcomes. Now let's do some probability, right? Letter B. Using the sample space above, find the probability if 2 coins are tossed, you get both a head and a tail. Well, as always with probability, what we want to do is find the ratio of the events that fall in, the equally likely outcomes that fall into the event that we care about, i.e. getting a head and a tail, compared to how many total there are. Well, there are 2 outcomes that fall into the category of getting a head and a tail. There are 4 total outcomes, so our probability is 2/4 or 1/2 or 0.5 or 50%, right? If you look back at my simulation, or better yet, look back at your simulation, did you, out of those 30 flips, did you get roughly half of them that landed on heads, 1 head and 1 tail, right? That's what, in theory, you should have. Now, letter C, using the sample space above, find the probability if 2 coins are tossed, you get 2 tails. Well, again, there is only 1 equally likely event out of 4 that fall into the event of getting 2 tails. So the probability of getting 2 tails is 1/4, or as a decimal, 0.25, or as a percent, 25%. All right. Now, that's not to say that you couldn't flip 2 coins 30 times and just by sheer and complete luck, they all end up being, 2 tails each time. Don't get me wrong, if that happened, if 30 out of 30 ended up being 2 tails, I would start to suspect that there was something funny about the coins, that they were loaded in some way that forced them to turn up as tails. But it could still happen. It's actually more likely that that would happen than you would win the lottery, I think. I'll have to look into that. But depending on the lottery, probably the case. So let's keep working with these compound events and understanding how we can list out their equally likely outcomes. Exercise number 5. A coin is tossed and a single 6-sided die is thrown. Both results are noted. Letter A, create an organized list that shows the sample space. All right, so we want to just do a list that shows all the equally likely outcomes. Now, obviously, when we toss a coin, right, that can result in heads or tails. All right. When we roll a single-sided die, that can result in the numbers 1, 2, 3, 4, 5, and 6. Okay, so there are 2 outcomes here. There are 6 outcomes there. We would expect 2 times 6, or 12, equally likely outcomes. If I take how many equally likely outcomes there are for one part of the compound times the number there are for the other part, that will give me my total. 2 for the coin, 6 for the die. There should be 2 times 6, or 12. Now, how can I list them? Well, I can list them actually in 2 different ways. I can say, well, let's say I tossed the coin first, and then I rolled the die, right? Then I could say, well, I could get a head and a 1. I could get a head and a 2. I could get a head and a 3, a head and a 4, a head and a 5, a head and a 6, right? That's all the possibilities that if I got a head when I tossed the coin, right? And then I got these on the die. Likewise, right? I could get a tail when I tossed the coin, and then I could get a 1 on the die, a tail and a 2, a tail and a 3, a tail and a 4, a tail and a 5, a tail and a 6. And notice, right, all together, I have 12 outcomes. And all of those are equally likely because it's just as likely that I get a head as a tail, and it's just as likely that I get a 1, a 2, a 3, a 4, a 5, or a 6. 12 total outcomes, 2 times 6. Now you might say, well, why did you put the coin flip first and the number second? You don't have to, right? You could have an organized list. I'm not going to write out the whole list, but you could have something like, well, I roll the die and I get a 1 and a head. And then I get a 1 and a tail. And then I get a 2 and a head. And then I get a 2, whoops, can't really move that. And then I get a 2 and a tail. And then I get a 3 and a head. And then I get a 3 and a tail. Right? You could also do it that way. And eventually, you'd have 12 of them. But keep in mind that, 2H here is the same as H2 here, right? That just means, hey, I got a 2 on the die, I got a head on the coin. That's what I ended up getting as a result. Now, let's use this organized list to find some probabilities. Letter B. Using your sample space, find the probability that a head and an even is thrown and a tail and a number less than 5 is thrown. All right. Well, you know the denominator. It's going to be 12. The question is, what are the numerators? Pause the video now and come up with those 2 probabilities. All right, we want a head and an even. Well, we know that there are 12 equally likely outcomes. How many fall into the event of getting a head and an even? Well, here's a head and an even, here's a head and an even, here's a head and an even. None of these fall into that event because they're all a tail. So the answer is going to be 3/12. All right, it's okay to leave it like that. If you chose to write it in decimal form, it would be 0.25. And if you chose to write it in percent form, it would be 25%. If the problem doesn't specify how you should leave your probability, I think any one of these is fine, including the simplified version of 3/12, which is, not surprisingly, 1/4. All right, how about a tail and a number less than 5 is thrown? Well, here are all your tails, right? And here are all your tails with a number less than 5, right? And we have 1, 2, 3, 4 of them. So in that case, the answer is 4/12 as a fraction. As a decimal, that one's not quite as nice because it's 1/3, which is 0.3 repeated. And as a percent, that would be 33.3%. And that's it, right? So the actual calculation of the probabilities doesn't change, right? That still works out the way it always has. We find the total number of equally likely outcomes, we find out how many of them lie in the event that we care about, and then we look at their ratio. The thing that's harder is actually counting and listing the equally likely outcomes. We'll see a lot more of this in the next lesson, but let's wrap this up, right? So up until this point in time, you've only ever found the probability of simple events. Events where we've done just one thing, flipped a single coin, thrown a single die, spun a single pointer, whatever. But now we get into compound events where we flip 2 coins, 3 coins. Maybe we pick 4 cards out of a deck of cards, something like that, right? Those are compound events because we are literally doing multiple things, right? Each of which is in itself a simple event. Now, listing out the equally likely outcomes then can be a challenge. And so far we've seen a way to do it with, sort of like tables. All right, that then results in ordered pairs, and also an organized list. And organized lists are a wonderful way to do it. Just by saying, hey, okay, well, this first thing can happen as a head or a tail. This other one can happen as a, 1, 2, 3, 4, 5, 6. So, head 1, head 2, head 3, head 4, etc. An organized list is a fantastic way to list all of the equally likely outcomes. Once you have them, right, then you can figure out how many fall in the event that you're trying to find the probability of. Again, we're going to work a lot more with compound events in the next lesson. For now, I just want to thank you for joining me for another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.